Assalamu alaikum. This will be a multiple part series on quadratic equations in which we will be covering what quadratic equations are, how to solve them, what it actually means to solve them, and what are the different methods we have for solving the quadratic equations. Now, the most general form of a quadratic equation is a x square plus b x, and then we have a plus c, and it all being equal to 0. This is the most general form of a quadratic equation that we have, in which a, b, and c are constants, while x square and x are the variables, in which x is the variable and x square would be the squared form of that variable. Now, the meaning of solving a quadratic equation is getting such values of x that if we put those values in this equation, we would satisfy the equality, in which it would be since here we have on the right hand side 0, we will also get a 0 on the left hand side. How do we get that? Now, we have three different methods to solve a quadratic equation. Now, the first method of solving the quadratic equation is completing the square. So it would be completing the square. Now, first of all, I'd like to tell you one more thing. A quadratic equation would have the highest variable power to be 2. Like here we have for x square. It can be y square as well, but it cannot be y square x square together like this. So this is something to keep in mind, that for a quadratic equation we would have the variable squared as the highest form available as a single term. Okay, and it can be on y square or z square, but we cannot have y square and x square together multiplying with each other. So first method of solving is completing the square. Second method is called using quadratic formula. And the third method that we have, if I could scroll it up, okay. And the third method that we have is called middle term breakup. Middle term breakup. Okay. These are the three methods that we have for solving a quadratic equation. Now, in this video, I'll be covering the completing the square method, and in the videos to come, I'll cover using a quadratic formula and middle term breakup as well. So, first of all, I'd like to tell you that all of these methods are quite literal. Like in completing the square method, we'll see right now that we complete the square to solve the quadratic equation. In quadratic formula 1, we are just using the quadratic formula that we will derive, and then in the middle term breakup, we break up this middle term right here to solve the quadratic equation. Okay, so let's jump right into the completing the square form. First of all, I'll have x square plus 2x, okay, x square plus 2x plus 15, sorry, it is negative 15 that I have here for the quadratic equation, and it all is equal to 0. Okay, notice that we have here a is equals to 1, then we have b is equals to 2, and then we have c is equal to negative 15. Okay, the sign matters. Okay, so for c we have negative 15. What I want to do right now is make it so that every single term is positive here. So to do that, I'll have to take this to the other side so that it becomes positive. Now, let's to take this to the other side, I have to add 15 on both sides, since that would cut out the 15 from here and give me a positive 15 on the right hand side. Okay, once we are done with that, I'll go towards the geometrical representation of the whole equation. Okay, so first of all, let's write the next step. It becomes x square plus 2x minus 15, and then I'll be adding 15 on both sides, so it would be equal to 0 plus 15. Okay, this would cancel out this, and then the equation that we'll have would be x square plus 2x is equals to 15. Okay, here we have a quadratic equation in which we have just taken the c to the other side. Now let's go towards the geometrical representation of this diagram of this equation. So we have, for first we have an x square. For x square, I can just say that it is a square of sides x. Okay, so I'll be writing that down. So it becomes an square of the sides x and x. Then we have a rectangle. I can say that this is a rectangle of the side 2 and x, since that is how we take the area, length multiplied by breadth. So I can just write it down as a rectangle with the side x and 2. So I'll say this is 2 and this is x. Okay, and then in the next part, I would say on the right hand side, I'll say that since I'm taking area on the left hand side, I'll say that this is also, it must be equal to some other area. So I can say that this is 15 units squared. Now I'll write down 15 units squared as a rectangle. Why I would do that, you would see in the coming steps. So this would be a 15 units squared rectangle, 15 units squared rectangle. So since we have area on the left hand side, we also have the area on the right hand side. So let's take it one step further. If I cut this rectangle in half, I'll get two rectangles of sides 1 and x, 1 and x. Okay, so I'll do that. So I can do that since I have 2x here, and if I break it down, I can write it as x plus x. Okay, so let's take it to the next step, in which we will have, first of all, a square. I'll just copy down the square here of the sides x and x, x and x. Next, I'll have this rectangle of the side 1 and x. I'll put this rectangle here, and then I'll put the other rectangle here. Okay, I'll show you here that. So this is the second rectangle that I have, and it has the sides x and 1 as well. Okay, I've done nothing but just switch up it a little. Okay, I've just split up the rectangle and then added it into different sides of the square, and all of this would be equal to the area 15 units squared. Okay, 15 units squared. Okay, all of this would be equal to the area of 15 units squared. Now, since the method was completing the square, can you see that in the left hand side we have a compound shape that can be completed into a square if I add a square of side 1 and 1 here. Okay, so I'll do that, and if I'm adding a square of side 1 and 1 to the left hand side, so this becomes a area of this would be 1 unit square. 1 unit square would be the area of this small square, since it has the sides 1 and 1, and 1 multiplied by 1 is equals to 1. I'll also have to add that same area to the right hand side, since that is how we solve the equations. If I add something on the left hand side, I have to add the same on the right hand side. So this would be 1 unit square. Okay, now if I write it all down into the equation form, what I'll get here is a square of sides x plus 1 and x plus 1. I'll write it down. So it is x plus 1 whole square. Okay, since it is the square of the side x plus 1, then this is equal to 15 plus 1 In the next step, I'll write it down as x plus 1 whole square is equals to 16. Okay. Now, what I can do here is I can take under root on the both sides. But first of all, I'd like to tell you that this is the completed square form of the equation. Okay. Now, to solve the equation further, I'll take the under root on both sides. This would cancel out with this, and since I'm taking a under root on the right hand side, I'll add a plus and a minus on the right hand side, since that is how we take the under root. The more detail of this that would be in some other videos where we would be discussing square roots and squares and how we do solve those. Okay, so for the next step, I'll have x plus 1 is equal to, okay, x plus 1 is equal to plus and a minus 4. Now we would solve this first for x for the positive 4 and then for the negative 4 to get the two values of x that would satisfy the equation. So the first would be, if I do it for the first, it would be x plus 1 is equals to 4, making x is equals to 4 minus 1, and this would give me x is equals to 3. Now if I solve it for x plus 1 is equals to negative 4, I would get x is equals to negative 4, negative 1, making x is equals to negative 5. Notice that we got two different answers. One is x is equals to 3 and the other one is x is equals to minus 5. Now if we put both of these values in the equation here, we would be able to satisfy the equality here. So these are the two answers that we get for x for the equation x square plus 2x minus 15 is equals to 0. Now there is one thing that bugs me a lot, okay, and it had bugged the ancient Egyptians and the civilizations before that as well, that why is there a value of x that is negative, and if we put that negative here, we would get the square to be of negative 4 side. The problem with it being of negative 4 side is you cannot visualize a square of negative sides. Like if we talk about negative, we either say that it is movement in the y-axis downwards, okay, downwards movement in the y-axis, that is negative, or leftwards movements or left movement on the x-axis is negative. Okay, when we talk about negative, we talk about it in a direction. How can we say that there is a length of negative units, or that that we would get an area of a positive area from negative length? Okay, so the same thing bugged the ancient civilizations as well, and the thing is they never considered this to be an answer due to that, and they only considered this as the answer, as this is the only thing that can be satisfied using this method, since we can just put x is equals to 3 to get the answer of since we can only have a square in which x can only be equal to 3, 3 plus 1 would be equals to 4, which would give us the answer. While putting it as negative 5, we would get a negative 4, and that cannot be really visualized as a square. So hopefully that solves a little bit of the confusion and also gives a visual representation of what completing the square method actually is. Now we would be doing a more generic, a more general form, or we will drive a general formula for the completing square method, and that would be done in the next video. For this video, just know that it is quite literal when we say that we are completing the square. As we can see here, we have completed the square on the left hand side, okay, and that we get two answers while the ancient Egyptians got one answer, and since we are living in the 21st century, we need to get two answers. So that will be all for the first video. See you all in the next part.